Okay, in this video we'll show you how we can use the PartMaster 2D CAD system to draw up the pin and then take it through into the turning software. So we've just started the CAD, so we'll start a new drawing, and what we'll do is you'll just use some basic construction techniques to create the shape. So taking the dimensions from the drawing supplied, I'm just drawing a couple of lines passing through the datum position, and then I'll draw some lines parallel to these. So these are the diameters. Okay, so that's the basic geometry. We'll add in a fillet at the front here, and then we'll use the intersect command just to split these items where they intersect, and then we'll just delete out the bits that we don't need. So that's just, we've drawn half of it. It doesn't matter whether we draw the top half or the bottom half. The Lathe software will work in either quadrant. So now we create what we call a profile of that. So a profile is something which happens in the Z-axis. A contour is something which happens in X and Y, which is for milling. So we'll define this profile, and we'll give it a bit of extra thickness. Okay, so that's created the profile. We'll save that away. And then we'll take that through into the turning software. Okay, so this is a new job, so we set up the machine tool with the tool change position. This is for a front or rear turret, or a rear tool post, or a front tool post, and this is also the safety in the home position. So this is where the machine will start and where it will end up. So the first thing would be to define some tools. So let's define a regular turning tool. It's working, approaching from the rear, and it's mounted on a rear turret. Select that tool for use. Set the spindle speed and the feed rate. If the machine has got constant surface speed, we can use it, and the feed rate can either be feed per minute or feed per rev. If it's got coolant, then we can switch it on here. So if we wanted to machine that groove with a turning type tool, then we could use that tool, and we're just giving it the two corners of a rectangle. So that would be the top right, and this would be the bottom left, and then we'll let the system decide how it can machine that. So that's based on the tool moving and with the angle of the tool, so that's as far in that tool can get into based on the tool angle. If we did it using a different tool, but this time a left-hand tool, and select that tool for use, then we can do the same thing. And set the cut depth to 1. So if we just animate that tool, we can see that moving around on the screen. So the tool cuts within the described envelope, and it will only cut in as much as the tool geometry allows. Now between each one of those passes, the tool is moving off the job and moving at rapid from the previous pass to the next pass, so that in effect will give you a chip break cycle as it's moved around there. So that's machined out as much as possible with that tool. If we went back and changed the internal angle of that tool to say a 55-degree tip on both of those tools, and we ran the tool path again, then obviously it will be able to machine more of that groove. Having changed the tip geometry, obviously now we could go back into that second tool path and machine and change the working envelope so that it only moved to clear out the material left by the first tool. So if we want to go back in and change that, we double click the entry and then change the tool path to here. Switch it into centerline mode. So the second tool coming in from the left is only working on this area here. So that's one method of machining that groove. If I just switch off those operations now, the next thing we'll show you is a grooving tool. So the grooving tool can be whatever width you want it to be, obviously. And then there's a number of different ways of machining that using a grooving tool. So the first one is just a simple groove. So if we give it the two positions for that groove, we can type in the exact dimensions if we know them, or we can choose them from the screen. The other thing that we can do is, when we're choosing the screen coordinates, if we right click, we can lock on to the actual geometry, so we don't need to know the sizes. It will just automatically lock on to the geometry. So those are the sizes that it's created. In this case we don't need it to use a check surface. Now, because this is just a simple grooving operation that's not based on any particular geometry apart from the cycle limits that we've given it, now that we've taken out the check surface, these details here become available to us. So for instance, on the right hand edge of the groove, which is this one here, we can add a lip detail. So we might want a chamfer at the top, which is 0.5, and we might want a fillet at the bottom, which is 0.5. It doesn't have to be the same value, it can be a different value. And then on the left hand side of the groove, again we could have a fillet in the bottom, make it 1 mm this time, and a chamfer at the top, 0.5. Okay, so if we animate that tool and just run the tool path, this is the grooving tool. So if we just slow down that tool path, it's using the full width of the tool minus the tool tip to determine its next tool path, and then it uses, when it's considering the right hand side of the tool here, it's using the width of the tool to determine the tool path, and then when it moves across to the other side it's using the left hand side of the tool. So if we just run that through again, and it adds on the fillet and the tip chamfer, even though they're not part of the actual geometry. So that's one method of using the grooving tool. The next method is using the grooving cycle, but just giving it a larger working envelope, but asking it to consider the profile as a check surface. So now it does the same sort of operation, but it will look at whatever geometry is there to determine where that tool is able to cut and where it's not able to cut. And the thing that does is that it gives a finishing pass going right the way along the job. Okay, so that's two methods of using the grooving cycle to produce that groove. Another method is to use the turning and facing cycles. So here we can use the working envelope to decide the parameters of where it's going to work between, but we can set the cut depth, whereas with the grooving cycles it will always use the width of the tool minus the tool tip. So you can see the effect that that's using a much finer depth of cut each time, but still working within the working envelope and the profile that it's encountering whilst it's machining that. Okay, so those are the types of operation that you can use, either using the roughing tool with left and right options to machine that. You can use a grooving cycle and add on the fillet and chamfers to the tip and root as you need to, or you can let it machine it based on the geometry that it finds. Now the geometry that it finds can be any geometry. It doesn't need to be in this case a rectangular groove. It could be something with a big radius at the bottom of it. So that's how that works. Within each of those operations you have parameters that you can change. For instance, you can leave allowances on for a finishing operation and get that to either machine it with the same tool or with a different tool. At any time during the cutting cycle, if you need to move the tool away to clear the swarf and so on, you can use the go to operation and then either drive the tool to its home position or drive the tool to an X and Z location, either at rapid or at feed rate, so that the tool can move away and you have a chance to clear out any swarf that's needed. So to do that you simply put in a go-to operation, and that always gets added to the bottom of the file, but then you can just click and drag that into the sequence. So between operations here it will do a grooving cycle, rapid away, and then come back and do the other cycle. If at the same time you wanted it to stop the spindle, then you can use the miscellaneous commands over here to put out a machine stop, an optional stop, or a spindle command, or a feed rate command. So any of these miscellaneous operations, for instance the spindle command, you can start it and stop it, and then when it starts the spindle, then you can set the new spindle speed that you need. When you've completed the machining cycle, you post-process, so that will then create the G-codes required for the machine tool, and there's quite a good range of post-processors that we have. If we need to make any changes for a particular machine tool from a basic G-code file, then we can do that. But when the post-processed output is created, it runs through all the available tool paths. If you want to stop it doing that, you simply switch off tool paths in the program operations window down here, and then it will only post-process the operations which are active. So if you have one job with one file that completes all the operations, but you just need to post-process a single operation, then you switch off the others and it will only do the one. So when it post-processes, then it opens up another window, and then that's your G-code files, which you can either send through to our own machine tool simulator, which I will show you here. Okay. So that's now calling up the machine tool simulator and passing it the G-code file, or a version of the G-code file that we created just now. The machine tool simulator is a general purpose simulator. It's not linked to any particular machine tool, but it is just for a standard 2 and 4 axis lathe. So the stock size that it creates when we get into the simulator is taken from the extents of the machine tool, the toolpath that we created. If we want to set up our own stock or import an STL file that has the stock, then we can do that. Okay, so the simulation just has straightforward video controls at the top here. So if we start the simulation, okay, so this is the actual part here. So that's created that part, but we can, as I said, the stock value here we can set them up to, so it's just machining the stock that we actually have, if you don't have to machine it from a full bar. Okay, so that's that.